There's a new set. We haven't done this thing ever before. Hope you will like it. Okay, so here we go. Final encounter of linear algebra. So the first question here. So those who are new, today we will be finishing off this. So while the session is going on, you can ask me questions as well. If you get stuck somewhere, then is also you're welcome to ask me. Okay. You're very free to interrupt me anytime you want. To be in short. Okay. So what is it? A 3 cross 3 matrix with a trace 3, determinant 2. If 1 is an eigenvalue, then what happens next? Then the matrix A square minus 2A is what? So what do you think on this for the first place? So first of all, we're dealing with a matrix which is a trace A. A is a 3 cross matrix. So let the eigenvalues are x, y, and z. This we can take. Trace of A is the sum of the eigenvalues, and determinant is the product. So x plus y plus z equal to 3, x, y, z equal to 2. One of them is this, so y plus z equal to 2, y, z equal to also 2. So consider lambda square minus 2 lambda plus 2, x square minus the sum plus the product equal to 0. If you solve it, lambda equal to 1 plus minus I. So y equal to, in this case, will be 1 plus I, z equal to 1 minus I, and x equal to 1. So all eigenvalues of A are distinct, hence it is diagonalizable. Isn't it? So the diagonalization is guaranteed by this. Next part is, once it has been guaranteed that we can diagonalize the system, so it becomes very easier for us. So A is 1, 0, 0, 0, 1 plus I. am forming like this, 0, 1 minus I with the eigenvalues. That's the principal diagonalization. So A square will be 1, 0, 0, 0. This is a 2i, 0, 0, minus 2i. So A square minus 2i, this formation will be very easy now. So this is like minus, remember that I'm not giving 0, not giving equal to 0. 2i minus 2, 0, 0, 0, minus 2i minus 2. Almost all of our job is done. So hence the eigenvalues of the matrix A square minus 2i is simply minus 1, 2i minus 2, and minus 2i minus 2. That basic formation is required. So one's answer is D. Now we talk about a linear transformation. Let's talk about linear transformation. Yeah, 3. A not equal to M, T, just enlarge it a little bit. T1 is the Rn to Rn, T2 is also this, the linear transformation. So if the transformation such bijection is being applied over here, and if such bijection is being applied over here, so what we can see. So normal formation, if we take T1, T2, isn't it 1 to 1? This is the n dimension to n dimension, so it has to form a 1 to 1. And hence, T1 is there, so T2 is also 1 to 1. Now the kernel of T2 is 0, rank of T2 is m. As T1, T2 is onto as well, so T1 is also onto. So rank of T1 is also n. So if these things are correct, so both of them are giving us the same rank, so they are D is the answer. Find the value of C for the following system linear equation has no solution. Very easy. No solution means what? Any idea? So you need to find the matrix and the augmented matrix, or rather say the extended version of the matrix. 1, 2, 3, 3, 7, C, 2, C, 12, 1, 2, 3. Okay. So now let's make some changes. R2 minus 3R1 and R3 minus 2R1 if I do, so you get two zeros. 0, 0, this is 2 and 3 and 1. No change in the topmost corner. So what I'm doing, R2 minus 3R1 and R3 minus 2R1. Clear? So in the very first place, this is 0, 1, C minus 9 and minus 1. And the next place 0, C minus 4, 6 and a 1. Next, after this, if we apply the change, then C minus 4 is creating a problem. So let's do R3 minus C minus 4 into R2. Okay, so work with the entire thing together. So there is no change here. So this is 2, 3, 1. This is 1, C minus 9 and minus 1. And here in this case, this will be C minus 4 minus this. So 6. No, sorry, this is 0. This is 0. This is 0. And this is minus C minus 4 into C minus 9. And C minus 3. Now the system linear equation has no solution. So the rank of A has to be less than 3. Okay. So this is only possible if this value is also 0. So if I do it C square minus 13C plus 30 equal to 0. So C equal to C and 10. Now C is not equal to 3, then again this will be equal to 0. So then it's a finite solution. So C not equal to 3. So only possible value of C is equal to 10. This is a tricky question. Even in the last case, when you have two solutions, finding it out. Remember that these two ranks cannot be same. If this thing becomes also 0, so then both the ranks of the matrix and the augmented matrix becomes 2. In the normal case, this will become 2 and 3. So the discrepancy is giving birth to the infinite possible solutions. Okay. Next. Next is 5a. Let A be a 3 cross 3 real matrix. Determinant of A is this. Find determinant of adjoint of A. Any idea? Shortcut you can tell me, help you out with. So determinant of adjoint is what? Determinant of A to the power n minus 1, isn't it? So determinant of the adjoint is nothing but determinant of A to the power n minus 1, where n is the order of the square of the matrix. So here, this is nothing but the determinant of the adjoint here. So that is 6 squared, that is 36. Clear? Not so tough, isn't it? What do you think in this case? Okay, basis and span we haven't done. We'll be doing it later on. Here we got one question. It's actually taken it from TIFR paper. I think some of the questions we have done in the last class. Okay, yeah, this I think we have done, yeah. P minus P, this question we have done. Okay, let's do with this 11. So we have vector space X equal to 0 dimension of V. So A equal to this thing. Okay, what is the rank of A? Let's find the determined value. 1 minus 3 minus 5, then minus 1, and minus 9, minus 1, so plus 1, then 1, 15, plus 1, 0. So rank equal to 2. You can do it in this way, or you can go with the row and column operation. Okay, as nullity of A is given as X, three-dimensional plane, X equal to 0, and dimension of V equal to number of linearly, what is dimension? Number of linearly independent solution of homogeneous system of equation. Clear? In Ax equal to Z. Ax equal to null matrix. So here dimension equal to nullity. Of A. So dimension equal to 3 minus 2 equal to 1. Okay. Obviously this is the correct answer. Dimension of W1, W2, the pairwise calculation. So this is also very easy. Dimension of W1 union W2 or plus whatever it is. So W1 dimension of W1, dimension of W2 minus dimension of W1 intersection of W2. So where in this case, what will be the value? Okay, A plus B, C. Remember that W1, if we take A and minus A, so A plus B equal to 0, so these two sum is providing you 0, and this two sum is providing you 0. So dimension of W1 is providing us 3, and dimension of W2 is 3. So dim W1 is 3 equal to dim W2. Okay, please ask me questions if you have any doubt in this now, till now. So these two dimensions are same. Okay, as two dimensions are same, all you have to put is the value and what is the common dimension of it. So remember that W1 plus W2 if I do, so all I get is A, so A plus B equal to 0 and A plus C in that way, so A, B, C, D, so this will be dimension of 2. So 3 plus 3 minus 2, so 6 and 4 is the answer. So 4 is the dimension. Yeah, tell me.
So how did you calculate this dimension?
Yeah, so let me just recalibrate this thing. So this is W1, A minus A, C, and D, right? So where A, C, and D, three things are used, these are real. Now, here I'm introducing another one, A, B, C, and D, where I'm saying that A plus B equal to 0. So now A, B, C, D are on this real plane. Okay, so now I'm introducing one more variable and getting into all distinctive situations. So 4 minus how many distinctive? So this is this. Now, if also in this case this is C and minus C, then that will grab in. So y W2 in the same way, dimension is giving us 3. Now, when it comes to W1 intersection W2, so what is that? So this is A, this is B, this is C, and D, where A plus B equal to 0 and A plus C equal to also 0 and A, B, C, D are there. Clear now? So there are two possible sets which we can form, and this was gives us a dimension. Next. Okay, how to consider the subspace of a vector space? So let me just tell you the 16 one. X plus 2y equal to, just take the two equations. Two equations, three unknowns, isn't it? So this is a line passing through the origin if we take. Okay, line passing through the origin if we take. So W1, which is of X, Y, Z. Three-dimensional real plane. This is a subspace of R cube. So which of the following is a subspace of R cube? So this is a subspace of R cube. Done. In the very next case, 2x plus 3y plus 4z equal to this and z equal to 0. This is not a subspace because it doesn't pass through origin. We cannot guarantee that it passes through origin. Okay. So if you put z equal to 0 over here, then 2x plus 3y equal to 3. Obviously, it doesn't pass through origin. So B is not the subspace. In x3, x is greater than or equal to 0, y. So x0 and y0 is a possibility. Okay. But even if you put these three values over here, okay, even if you put x1, x greater than or equal to 0, y greater than or equal to 0, three-dimensional plane. So here, so this is a three-dimensional basic plane. So alpha 1, 2, 3 is actually will be giving you three different values. Okay, minus 1, 2, 3, which will not be a form. So this is also not forming a subspace. And the last case, x minus 1 equal to 0 and y equal to 0 doesn't pass through origin at all, because the first one gives you x equal to 1. So this is also not a subspace. So only A is the answer. So just getting the zeros and that's it. Next, again, an easy one, linear transformation defined by this for all x, y, z. Then what is the value? Okay. So what you have to do, x and y. So 1, 1, 0, y, z, y, z, zx. This is stuff. Okay. So this is a standard basis also. What is the standard basis? 1, 0, 0. So if we take the standard basis on a three-dimensional real plane, okay, the t of 1, 0, 0, how you can represent it? Or 0, 1, 0 or 0, 0, 1. This can also be represented in a very similar way. Okay, so now all you have to do is the transformational change. just like the ones which we have done. I'm just keeping it as a homework then. And remember that one more formula which will be needed, rank plus nullity equal to dimension in order to solve it. Now we have an inconsistent system. Again, augmented matrix and these two, and their ranks need not to be same. From the augmented matrix and unequal rank with the main matrix. Clear? I think you will be able to crack it. So the main matrix is 1, minus 1, 2, 1, 2, and minus 1, 0, 2, and minus 2. When it comes to the augmented together, B1, B2, and B3. The 19 is very easy. A equal to this matrix, be a matrix with the real entries, all the entries are real. If some of the product of all eigenvalues of A are 10 and 30 respectively, then A square plus B square. This I think we have done anyway. I don't. In this batch, have we done this thing? 19? Anyone remember? Okay. I hope I haven't. Now, let's do it. So these are all real entries if the sum and product of the eigenvalues are this. Okay. Sum and product. Sum and product. So in this case, sum of eigenvalue is 10, product of eigenvalue is 30. Sum of the eigenvalues of this is the trace. So A plus B plus 3. So A plus B equal to 7. As the product of the eigenvalue is nothing but the determinant, so 30 equal to 3AB, so AB equal to 10. So A plus B whole square formula, so 49 equal to A square plus B square plus 20. So A square plus B square directly gives you 29. So that's option number A. So let's quickly, let me see how many questions we have here. $61. Do 21 here. You can also ask me for any hint if you get stuck for any question. So anyone need help in 20? You can ask me. Yes or no? Please tell me. 20, you can handle it? Or you want me to give you a hint?
Okay.
Okay. Consider the equation of the subspace W x1 x2 xn 10-dimensional real plane xn equal to x of n minus 1 plus x of n minus 2 and n lies between 3 to 10, the vector space of R10 dimension of W. I think we have done it. Yeah. But anyway, as you have asked, so I should do it. So W equal to this thing. Okay. So x3 equal to x1 plus x2 we can say. Then x4 equal to x3 plus x2. So that is x1 plus 2x2. Why? Because this will again be replaced. x5 is x4 plus x3. x4 is x1 plus 2x2. And x3 is x1 plus x2. So 2x1 plus 3x2. Okay? And so on. So thus for xi, 3 less than equal to I less than equal to 10, can be expressed as a linear combination of x1 and x2. So linear combination of two variables, so it becomes a dimension. So dimension of W is 2. So dimension says that in order to represent that given structure, how many different variables you need. That's it. Next one. Is a n cross n matrix with real entries A square equal to A. If I denotes n cross n identity matrix, then show that A minus I is a nullity of A. This is a proof, but anyway, I will do it. This kind of proof becomes handy in order to improve your thing. Idea. So A is a n cross n matrix with real entries A square. So A is an idempotent matrix. Rank of A equal to trace of A then. So nullity equal to nullity of A is what? N minus rank of A. So rank plus nullity equal to N here. Because trace is equal to N. So N minus trace of A. And this is by the rank nullity theorem. So N minus trace of A, we can write trace of I minus trace of the identity minus trace of A. So trace of I minus A is rank of I minus A. And that is rank of A minus I. So nullity of A is nothing but rank of A minus I. Hence proved. Easy proof, very small 3-4 lines, but yet effective. And don't think that if you are asked to do any proof, so you have to make it as long as possible. A, B are distinct non-zero real numbers, A, B equal to C plus D, then the eigenvalue of the matrix. Eigenvalue of the matrix. So here you can take arbitrary values. Choice. And calculate. Every value pattern is applicable. And you can take a combination of like A equal to 3, B equal to 2, C equal to 1, and D equal to 4. It's like A plus B equal to C plus D in this. Okay. So always remember that in these kind of cases, once you do it and you form it, you have to cross check that A plus lambda. So lambda equal to A plus C. So this is not possible. So this is not possible in that way. Okay. This also I'm giving as a homework. Don't worry, the entire PDF will be sent to you. So you get to do your stuff from this. 23 is A equal to 0, 1 minus I, minus 1 minus I, and I. B equal to 80 into A bar, then which of the following is true? Okay, B equal to 80 into this, so 80 into. Okay, we need to do a multiplication. 0, 1 minus I. So the transpose, so minus 1 minus I, 1 minus I and I. Into is this. So this will be 0, 1 plus I, minus 1 plus I, and 3. So minus. Zero into 0, minus 1 square, 1, 1, so 2. I minus 1. Minus I minus 1 and 3. So the characteristic equation is given by x square minus trace of b into x plus determinant of b. That is equal to 0. This we know, I hope. So x square minus 5x plus 4. So x equal to minus 1 and 4. So all the eigenvalues are purely real. So option number C is correct. Again, a linear transformation, very similar to the ones which we have done. Matrix entries A11 dimensional vector space. Linearly independent vector of 2 cross 2 real entries x equal. Okay, this is a little bit, there's a shortcut for this. So, you know, if the set is linearly dependent on the vector space of all 2 cross 2 matrices with real entries, then x is equal to 1. So that is A into this plus B into this plus C into this. And this is equal to, due to this reason. So first is AX plus C equal to 0. Then minus AX minus B minus C equal to 0. Minus A plus BX plus C equal to 0. And BX equal to 0. If you solve it from 1 and 2, we can very easily get B equal to 0 and minus A plus C. So A equal to C. Substituting Ax plus A equal to 0, Ax plus 1. So this is A equal to 0 or X plus 1 equal to 0. So if A equal to 0, then this is also C equal to 0. And which is a contradiction to the fact that none of the A, B, C are 0. So obviously X plus 1 equal to 0 and X equal to minus 1. So in that way, by arbitrarily taking values and taking a given coefficient, we can solve it very easily. Next. Very similar the 28 with 27. Let's try 29. Give it a shot and send it to me. You have 2 minutes in hand. So how to do it? P and Q are the two real matrices with the size 4 cross 6 and 5 cross 4 respectively. Rank of Q equal to 4, rank of QP is equal to 2, rank of P is equal to 1. So just like a divisional algorithm based thing, see how you can do it. Solve and send it to me. Send me quickly. Okay. Five of you tried well. See anyone else also. Okay, P can be P and Q on this. So rank of QP is less than equal to minimum of rank of P, comma rank of Q. That's for sure. So rank of P is greater than equal to rank of QP. So rank of P is greater than equal to 2. So now if A is um, M cross P and B is P cross N matrix, then rank of AB is greater than equal to rank of A minus P. So rank of QP greater than rank of P, rank of Q minus 4. So 2 here is this value, rank of P plus 4 minus 4. So rank of P is less than equal to 2. Now from here less than equal to 2 and here it is greater than equal to 2. So the only possible value is 2. What is the largest eigenvalue? 31. Without calculating obviously. So let lambda 1 be that I guess the largest eigenvalue. Okay. Lambda I rather say. So the mod of lambda I is less than equal to maximum row sum, isn't it? So maximum row sum is every time it is 21. So lambda equal to 21 is an eigenvalue as well. So option number B is correct. See, within seconds we can solve. You know, in examination, our target is to do this stuff only. So you need to go for some sums and finish it off very quickly, and then only you can target the others. And this week there will be a special class will be taken by Professor Shubhomol Chatterjee. I will ask him to take it on a Saturday evening, possibly. Okay, so you'll get the links for that. Uh, Today, actually, I will be wrapping up a little bit earlier, so you will take it forward in the linear algebras all these questions on that special session. So 33 is m equal to 0 and these much values are also 2 alpha and minus alpha are and be a non-zero vector such that m is equal to b and some x equal to three-dimensional real plane, then what is the value of x cube b? Okay, so m is this value, mx equal to b, and so x transpose, mx equal to x transpose b. So let's just multiply x transpose both sides. Let x equal to x1, x2, x3 is a column matrix. 3 row 1 column, 3 comma 1, inner three-dimensional real plane. This one also applicable. So xtmx. So this one will be x1. Transpose of it will become a row matrix. 0, 1, minus 2, minus 1, 0. Alpha, 2, minus alpha and 0. And then alongside this, you multiply with the x1, x2, x3. So now once everything is been sorted out, you get a row matrix anyway. Okay. So finally, minus x1 x2 plus 2 x3 x1 minus alpha x3 x2. Instead of plus x1 x2. So this is 0. So x transpose V, x transpose mx equal to 0. You can always cross check, and so option number C is correct. Have a look. If you have any doubts, ask me.
So that is X in the last means before finally in the line, the matrix in the right hand side.
Yeah, that is x1, x2, x3. This is the same thing.
Okay. Okay.
I've not written it here. Okay, so let's proceed to the next one now. If I'm skipping, that doesn't mean you need to also skip it. You can ask me any questions on doubt here. Okay, let's do. Yeah, this dimension is a very complicated one, very unique question. So give it a try.
So what is the vector space? Like which vector space they are asking for? Y.
Dimension of the vector
Uh,
space, yeah. Then the dimension of the vector space y in a three-dimensional given ay equal to 0 over r. Okay. Any way out? So x1, x2, x3 are q on a real non-zero vector and ax xt xt by x the dimension of the vector space. So here in this case, understanding the problem is a little bit tricky. So let me just split this part. So you just think, okay, you don't need to split this part. Okay. So
So
here,
that should be one, right? Means A
no,
x
no, 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 no.
xt
It
by
is not equal to BA, na? So that's why. We can't write it in that way. So here, this thing. So 1 by, and if you multiply x1 squared, x1, x2, x squared. So as a non-zero vector, so we can take it x1, x2, x3. This thing. So without the loss of generality, let x1 not equal to 0. So obviously a equal to x1 square and sum of xi square. This will be 1 and x2 by x1, and this is x3 by x1. This is x2 by x1. This is x2 by x1 square. And this is x1 square. Then this is x3 by x1, x2, x3 by x1 square, and x3 by x1 square. Now, from R2, if we take R1 and R2, by R1. So in this case also, this all will be 0. So we will be ending up with x2 by x1 and x3 by x1. So finally, if we see the vector space where the formation is ay equal to 0 over this real plane. So this is giving us, this rank is what? Number of non-zero vectors, so rank of A is this one. Nullity of A, two variables are remaining. So x2, x1, 3 minus 1, 2. So dimension of this thing is 2. So dimension of the vector space will be 2. So this is a theoretically they have given this part. So the main question starts off with this, ends up with this. So once you, and remember that this is a summation of xi square means x1 square plus x2 square plus x3 square. Okay. So you just remember that every time when you solve these questions, you just have to get yourself rewarded, okay, with a possible answer. And this possible answer only comes in if you read this last part keenly. Here also, m alpha beta gamma is this, where this thing. So the determinant equal to 1 in this case, they want to say. And x, x1, x2, x3, mx equal to 0 has infinitely many solutions in trace of m. That's the last question I'm going to do today. So m and all these things, mx equal to 0, infinite many solutions. So let's put this mod m equal to 0. So alpha beta gamma minus 1 minus beta gamma minus 1 plus 1 minus beta equal to 0. So alpha, beta, gamma minus alpha plus beta plus gamma plus 2 equal to 0. So alpha plus beta plus gamma is alpha, beta, gamma plus 2. So alpha, beta, gamma is 1. So 1 plus 2, 3. So very easily with ease we can do it. And on this Saturday or next Sunday, the rest of the part will be done. And that's it for today. And I'm sending it to you all this PDF as well. So today, within this week, we hopefully will be able to finish this up.